For those of you that don't know me, this is Zach Stone PE. I'm the lead instructor for electricalpereview.com. We've been helping electrical engineers pass the PE exam all around the world since 2014. If you'd like to read the entire article that we're going over here in this video, make sure you click on the video description down below. There's a link directly to this article. All right, it's a really exciting time in the electrical power PE exam world. Today, January 15th, NCEES have officially released their reference handbook for the upcoming electrical power CBT exam. So this is the much anticipated computer-based testing format of the electrical power PE exam that up until now has traditionally been paper and pencil. So we reviewed the entire 75-page handbook today in detail and made an article noting all of our surprises and things that you need to know if you're planning on taking the new CBT exam. And our main takeaway is that if there's no changes made to the exam, expect it to be much more difficult. And the main reason why is the reference material, right? The reference handbook is pretty small. It's only 75 pages long, and it's a lot shorter and more simple than what you're used to bringing with you. So the CBT exam is actually going to be closed book. So traditionally, the PE exam has been open book, and most engineers have been able to essentially bring a small library with them. All right, in this video, we're basically doing a podcast form of this article. We're going to talk about the open versus closed book differences and how the CBT format will use the reference handbook. Then we're going to talk about the differences between the reference handbook layout and outline, especially compared to how it differs from the official NCEES exam specifications outline. Then the biggest surprise, the lack of protection. Yep, that is not a mistake. There is no protection in the reference handbook. So we'll talk about why that's so surprising and what to expect. Next, the second biggest surprise is a lack of codes and standards, also very surprising. After that, we're going to talk about some of the main things that jumped out after reading through all 75 pages, and that is engineering economics, symmetrical components, instantaneous functions, average value and RMS, rotating machines and transformers. Then we're going to wrap it up with the final thoughts on the new CBT reference handbook and what it means for you if you are taking the new CBT exam. Then I'm going to show you how to log into your NCEES account and download or print the new reference handbook. Unfortunately, we can't show it to you because, of course, it is copyrighted material, but don't worry if you already have an account with NCEES. You can quickly log in and download and print your own copy. So it's available as of right now. So after watching this video, you can go ahead and directly access the reference handbook. Then there's just a couple of useful links that if you haven't seen them on the official NCEES page, they might be helpful for you to be familiar with. And then last, if you have any questions, of course, you can always leave comments directly on either the article that we're reading or on this YouTube comment, right? We respond to all comments. So any thoughts, questions, or concerns, feel free to drop them below and join in on the discussion. All right, so the main difference is up until now, traditionally, the exam has been open book. And notoriously, the electrical power PE exam has been known for having a very high number of just difficult questions that cannot be answered without these reference books. So most engineers have taken advantage of this by bringing quite literally about 10 to 15 different reference textbooks or large 3-ring binders filled with case studies and white papers. And essentially, the last 30 minutes to an hour of the morning and afternoon sessions, they've used these reference books to cram as quickly as they can and find answers to some of those more difficult questions, especially the really tough qualitative-based questions. Just like in the real world, in the engineering industry, you're not expected to know everything off the top of your head, right? That would be just too unrealistic. However, you are expected to be able to quickly find answers to new challenges in things like IEEE standards, code books, and case studies. So again, historically, the paper and pencil format for the electrical power PE exam, it tests on your same ability to use references. So now the CBT format is absolutely closed book. And so far, the only thing that NCEES has stated that they're going to give you is this new PDF 75-page reference handbook that you'll be able to access on the computer while you take the computer-based test for the PE exam. So how does this new reference book stack up to reference books that historically we've been able to bring with us in the past? Well, as you can expect, the reference book, it's only 75 pages long, and it's mostly just bare formulas with little explanation. You know, the power exam, the scope is just too large to be able to memorize every single detail being tested on. It's just too big, right? The field of electrical engineering, it would almost be impossible to find a subject matter expert on every single industry that would be able to answer questions quickly off the top of their head. So with only a 75-page essentially cheat sheet for each topic, the reference book doesn't really stack up to essentially the small library that engineers used to bring in. We can laugh about it and joke, but it wasn't uncommon to see engineers showing up to the electrical power PE exam with little mini bookcases or sometimes coolers on wheels that you'd bring to the beach, except stuffed with academic textbooks or luggage on wheels, you name it. I think when I took the PE exam back in 2014, I used two of my biggest books to make kind of bookends, and I lined up about 20 different books on top of my desk. So that is no longer the case. So right now, the way we view it is the electrical PE exam has always been notorious for really tough qualitative theory questions and just being so broad in depth that you need reference material. So it's really hard to imagine that the new reference handbook is going to be much help in answering these types of questions when we compare it to the references that we've been able to bring in the past. So here's my thought. Here's my thought process. If the question difficulty doesn't change on the new CBT exam, expect this to make the electrical power PE exam much, much more difficult than it already is. Now, before we jump to the second topic, just how difficult is the electrical power PE exam? Well, let's go ahead and look at the most recent pass rates on the NCEES website. All right, this is directly from NCEES.org. This is publicly available on their website. And if we look at the most recent pass rates, right, the April 2020 PE exam, of course, was canceled due to COVID-19. So the most recent results are from December 2019 after the October 2019 exam. So if you look at this, here's electrical power out of all of these PE exams, and look at the pass rate for first-time takers is only 50%. And the pass rate for repeat takers is only 26%. So if you look at, there's 23 PE exams in total. If you look at this pass rate column for first-time test takers, you'll notice that the electrical power PE exam has the lowest pass rate compared to any other PE exam for first-time takers. For second-time takers, I believe it's the second to lowest, right? If we look down here, marine engineering for naval architecture was 27%. So it's still just about the lowest pass rate even for repeat takers. This means the electrical power PE exam is by far the most challenging PE exam that NCEES currently has. So if they don't change the level of difficulty on the new computer-based format, if they don't make the questions less qualitative, or if they don't make them easier to answer with the reference handbook, then I don't see any other way that this exam is going to get any easier. All right, back to the changes with the new reference handbook. How about the layout and the outline in the table of contents? So here's a quick table that shows the layout. On the left is the exam specifications outline, right? That's a document you're probably very familiar with that has the 13 overall subjects and their individual subtopics. And on the right is the table of content outline for the new reference handbook. So I'm not sure what the point of this was, but if you'll notice, they don't really match up. First of all, the exam specs use Roman numerals followed by letters and numbers, and the reference handbook just uses numbers. And some of the topics are kind of in different orders. Again, was there really a purpose of doing this? It was probably just a simple oversight and not on purpose, but it's really important to know where everything is located. That way, when you're looking for certain topics, you can find them quickly. Now, the good news is when you use the reference handbook during the CBT PE exam, you can use Control F. Let's see if I can pull it up on screen right here. So if I type in, if we want to go back to that outline table, if I type in outline and I click next a couple of times, look, I jumped right to this keyword. So just like I was able to search on this website with this article, you'll be able to use the same Control F search inside the browser window or the PDF viewer when you use the reference handbook when you take the PE exam on the computer. So that is helpful, but if you're just scrolling through it, again, it's really important to take some time, look through the differences. In fact, I recommend print out the exam specs outline from NCEES. We've got a link to that website on the bottom where it's located, and print out the new reference handbook and compare them side by side. Really make sure you know where everything is located. In addition to that, there are some interesting points too I'd like to bring to your attention. The biggest difference is engineering economics. So in the handbook, it appears in Chapter 1, General Engineering, right? And in the exam specs, engineering economics appears in applications. Now, I included it in this outline just so we could point that out, but on the exam specifications, engineering economics, it's not its own topic, right? It falls under applications. So you'll notice there actually is no chapter 1 general engineering in the exam specs. So this is a new topic that appears in the handbook. It has a lot of math that frankly hasn't really been tested on the PE exam. And we'll talk about more of that in a second, but engineering economics, it appears in general engineering instead of applications. And applications does appear on the reference handbook outline. So again, no idea why engineering economics did not show up under applications. Instead, it showed up in 1.4 earlier on, which is the first chapter of general engineering. All right, after that, you'll notice protection is not included in the reference handbook outline. Just like we talked about in the beginning, and we've got a whole part of this article dedicated to talking about that, but strangely enough, protection does not show up in the reference handbook. What's interesting to note is that a large number of calculus, derivative, and integration identities, just about all of them, show up in that same chapter 1 general engineering chapter. Now, this is a little strange because the PE exam for electrical power doesn't really test on derivatives and integrals. The only place you even see a little bit of this is for power electronics, which is also under 2B2, power supplies and converters in the exam specs. Power electronics, sometimes you have to calculate the RMS value or the average value of a function. And to do that, you integrate over the entire period. So here's the thing, you don't need calculus integral identities to do that, because as long as you're decent enough with your calculator, you can just punch in the integral in your calculator. You can set up the upper and lower limits, and your calculator is going to do all the legwork for you. It's going to give you a numerical value for the average value or the RMS value. You're not going to need to know the integral identities like substitution or cosine, sine, that kind of stuff. The calculator is just going to spit out a raw number for you. So again, you don't really need to know this stuff. So why they included it in the reference handbook, we're not really sure. All right, so wrapping up, just be sure to familiarize yourself with the layout ahead of time so that you'll know where to find the information you're looking for. All right, number 3, the biggest surprise is lack of protection in the reference handbook. This is very strange. In 2018, NCEES made the first changes to these exam specifications, and it made protection the largest subject on the PE exam. There's a total number of 13 approximate questions out of 80, meaning protection is 16% of the entire PE exam, which of course could be the difference between passing and failing. If someone did well in all the other subjects but got every single question wrong in protection, chances are they're not going to pass the PE exam. So yeah, really strange. There is absolutely zero information on protection. And in fact, the only thing even remotely related to protection in all 75 pages of the handbook were a handful of ANSI device numbers and suffixes. And that's located in chapter 316, single line diagrams. And if you want to compare that, there's actually over 250 ANSI device numbers, descriptions, and suffixes total. Click this link, go to the Wikipedia article that lists all of them. You'll see it's huge. So the reference handbook only includes 7 out of the over 250 total ANSI numbers, descriptions, and suffixes. So this seems like it's extremely lacking. You know, protection is a really technical subject, and there's a lot of different application questions that could be asked on it in addition to the quantitative math-based questions. You know, we're expecting to see things in the handbook on maybe differential protection, difference relays, tap settings, pickup settings, time current curve graphs, right, TCC graphs, information on coordination, maybe time delay settings, inverse versus very inverse, extremely inverse, or moderate curves, damage curves for things like insulation, maybe even inrush curves for motors or transformers, you know, just basic breaker settings, fuse settings, zone of protection, backup protection. None of this was included in the reference handbook. So again, very surprising. Was this just somehow overlooked or a mistake? I'm not really sure. And this only kind of brings more questions than it answers, such as, does this mean the PE exam will only be testing on the 7 device numbers and suffixes from now on that they included? Of course, I doubt that. Does this mean that the largest subject on the PE exam, right, those 13 number of approximate questions, is it going to be removed from the PE exam? No, right? That's extremely unlikely. And will protection be included in future versions of the reference handbook, right? Maybe NCEES will update it before the upcoming January exam. Unfortunately, only time will tell. But, the most important thing is don't ignore protection just because it's not there. If all you study is on the handbook, you're going to miss the largest subject on the exam. And protection continues to be an ever-evolving industry in electrical engineering, right? Modern technology continues to influence the newer microprocessor-based smart protection relays. The industry's come an extremely long way from the electrical mechanical-based relays. And now with the emergence of more smart distributed electrical grids, protection is going to continue to be tested on heavily on the PE exam. So again, no idea why really it was completely excluded from the reference handbook, not even some general information. So really interesting to see how that plays out in the future with newer revisions of the handbook. All right, for codes and standards, the second biggest surprise. So right behind protection, codes and standards is the second biggest subject on the PE exam. There's 12 approximate number of questions, making up 15% of the overall 80 question PE exam according to the exam specifications. So if you go to the handbook table of contents, codes and standards appears in chapter 2.3. When you flip to chapter 2.3, the only thing listed there are just the list of code books that the exam tests on. It's the same list that shows up in the official specifications, right? The actual exam outline. So this is really interesting. Codes and standards, it's the second largest topic. It would be extremely unrealistic, even for someone that uses code books daily, to be expected to accurately answer code questions without having the code book next to them. Even just thinking of aspects of the code book, especially the NEC code book that engineers use the most often, think of the transformer overcurrent protection table. I'm sure everyone listening to this has used that table, either on the job or studying for the PE exam, to maybe size a fuse or a breaker for a transformer, either upstream or downstream, right? Primary or secondary overcurrent protection. It's all based on percentages of the transformer full load current, but you got to look up based on, is it in a supervised location or not? Is it under 6% impedance, right? What's the voltage? There's a lot of different values to use that table to look at the specific percentage to multiply the full load amps to find how you should size the breaker or the fuse. Another good example is think about voltage drop. Chapter 9, Table 9 in the NEC. It's the effective impedance for conductors for voltage drop, right? That's a table that everyone is typically familiar with because it comes up a lot in practice exams. How would you be expected to know how to pick the right value out of hundreds of values in that table to use for a specific conductor size based on, of course, what's the size? Is it 250 kcmel? Is it 8 American wire gauge size? Is it in PVC conduit? Is it in steel conduit? Is it copper wire? Is it uncoated copper wire? There's just too many variables to be able to be tested on this stuff without the code book. So again, really interesting that no code information was included. If I'm not mistaken, I believe the mechanical PE exam, which transitioned to CBT right before the power one, I believe they have a couple of tables included in their reference book from their code book. So again, really it's just going to take time to see how this plays out. Another interesting thing to point out, maybe you didn't know this, but if you go to nfpa.org, you can actually access just about every one of the code books for free within your browser. So, all I can think of is NCEES, they're going to have to let you either bring in your own code books, or they're going to have to somehow give you access to them. Maybe you're going to access them for your browser. It's just not realistic to be tested on these code questions without the code books in front of you. So again, just like the lack of protection, this raises more questions than answers. How are code books really going to be tested on the exam if so far we're not sure of how we're going to access that information? All right, number 5, engineering economics. So this is really interesting. Out of 8 of the total 75 pages in the reference handbook, right? So 10% of the reference handbook is dedicated to engineering economics. But engineering economics, it's a very small percentage of the exam. So according to the exam specifications, engineering economics falls under applications. There's a total of 8 approximate number of questions for applications. But there's also a total of 8 subtopics within applications, which engineering economics is one of. So if these are evenly distributed, that's about 1 question per subtopic of applications, right? So, on average, you're looking at only one question in engineering economics, maybe two, it depends, three at most, but we've got 10% of the handbook was dedicated to one individual tiny little subtopic that only makes up 1% of the electrical power PE exam. So yeah, I just thought that was interesting. Why take up so much space in the handbook when there's questions that get tested on way more frequently and questions that have a lot more info that could be helpful for the exam. Now, I will say one thing, the reference handbook, they were generous to include interest tables. Interest tables make the calculations, for example, if you look at this cash flow diagram, instead of having to use the P given A or the A given P formulas, which those aren't too bad, but when you do with things like geometric gradients, the formulas are much longer and complicated. It's easier to make a mistake when you're punching values. There's a lot of exponents, there's negative numbers, there's percentages. The interest tables make it a lot easier to just sub in that interest number, decimal value, instead of having to punch it on your calculator. So it does make the calculations a lot quicker. So the handbook was definitely generous to include those interest rate tables. All right. Conclusion for engineering economics. Just remember, hey, this is 1% of the exam, so don't be put off or don't be misled by how many pages appear in the reference handbook for engineering economics. All right, number 6, moving right along. Symmetrical components. It's easily the most hated subject on the electrical power PE exam, and I don't say that lightly. In my opinion, it's the most technical. And symmetrical components, it's not really used that often in the industry. Symmetrical components was mostly used before we had really sophisticated computer modeling. Very rare would you ever do any of this stuff by hand. So most electrical engineers aren't really exposed to this stuff outside of a classroom setting. Subject is really difficult because each of the different types of faults, let's see, 3-phase faults, double line to ground faults, single line to ground faults, they all use different single phase equivalent circuit models. So if you've worked symmetrical component problems before, you know that each fault has a different model, right? Maybe, you're familiar with the single line to ground fault, looks like almost a backwards E. Well, here's the thing, those circuit diagrams are not included in symmetrical components. Typically one of the things I teach is it's not usually beneficial to memorize things. There's just too much to memorize. If you memorize, you're going to apply things wrong. It's a lot easier to learn how to derive things. You'll come to conclusions in a more intuitive manner. Problem is, it's really difficult to derive these circuit equations. Even myself, when I'm solving symmetrical components, and I do this for a living, I reference the circuits just to make sure I don't make a mistake. And after you reference these circuits, each circuit, right, each individual fault type has its own formula to solve for the short circuit current. And that's really what makes symmetrical components so challenging. Using the right circuits depending on the fault type and then using the right formula for the specific circuit model. Well, unfortunately, none of that is included in the reference handbook. In fact, symmetrical components had the least amount of reference material than any other subject. The only thing it had included in the reference handbook for symmetrical components were 2 formulas. The first set was to solve for voltage from the voltage sequence components, and the other set of formulas was solving for the voltage sequence components from just the voltage values. The other problem and strange thing is these were given in the matrix form. If you're familiar with matrices, it's not too hard to understand them to get the individual formulas, but if you're not, then you're gonna scratch your head when you see it for the first time. In other words, you've got, a couple of 1x3 or 3x3 matrices to represent 3 individual formulas. And symmetrical components, it's already kind of difficult and tough to learn at first, so why make it more difficult? And the other thing is the PE exam doesn't really test on matrices. Maybe you saw matrices in the FE exam, but most people taking the PE exam, it's been a long time since you took the FE exam. Some take it back to back, but most don't. Most take the PE exam much later in their career. So again, why give the matrix formulas? Why not just give the individual formulas like you see them in standard textbooks? So really strange, really bizarre. The other interesting thing is the formulas for current and current sequence components were not given. Now they are identical with the A operator when you compare them to voltage and voltage sequence component formulas, so you can just swap the V's for the I's. But again, if you've never done this before, if you're just looking for that formula that you need to solve a problem, you might not know that. And especially when you're rushed and you're taking the exam and you're stressed, it's going to be really difficult. What else? So the main takeaway is, that's one of the best things. As soon as you get the reference handbook, jump to this chapter in the reference handbook and look at how bare it is for symmetrical components. So definitely make sure you're familiar with symmetrical components. Don't rely on what's given in the reference handbook to get you out of trouble. Now, the good news is, symmetrical components, again, it's a very, very, very small subset of, I believe it's analysis. So, don't spend an disproportionate number of time trying to master this, right? You're only going to see 1, 2, 3, maybe at most questions on symmetrical components. So, don't feel like you got to understand every single question possible on symmetrical components to pass the PE exam. All right, moving on. Number 7. I thought this was really interesting too. So in the reference handbook, you've got information on instantaneous functions, average value, and RMS. Basically, here's an instantaneous function right here, right? Typically, it's in the form of V peak times sine omega t, or I peak times sine omega t for your instantaneous current. Really, you only see this stuff inside, it's commonly known as power electronics, but in the exam specifications, it's spelled out as power supplies and converters. So for the PE exam, the only time you're dealing with instantaneous and peak functions is when you're working within power supplies and converters. Any other time outside of that, we're dealing with just RMS values, right? A magnitude and an angle, or a real component and an imaginary component. So those are the instantaneous formulas, except represented in the phasor domain. It's typically the way we're used to working with things in the power engineering field. So the interesting thing about this subject is it was not included in power supplies and converters. For some strange reason, this information was included under single-phase AC circuits. So in the reference handbook, that's under 314 single-phase circuits. Now, the reference handbook does have a section for power supplies and converters, and it's chapter 322. It's a little bit after this, but again, it's just really common. It's just really counterintuitive. It's not where you it's not where you would expect to find this stuff. So again, really important to be familiar with where everything is located, because this is all you've got. You don't get to bring in your 10, 15, 20 book library, your every white paper you found on the internet printed out, your IEEE standards, your college notes. This is all you got. It's just this small reference handbook. So make sure you know where everything is located. All right, moving on. Number 8, rotating machines and transformers. In my opinion, when it comes to qualitative questions, rotating machines and transformers is the most difficult subject for qualitative theory-based questions. It's such a big subject, and you got a lot of numbers, and you got a lot of approximate number of questions that show up according to the exam specs. The application side of both, the material side of both, how they're made, the amount of theory questions I can ask, they're almost endless. And the gold standard that I like to compare to is Theodore Wilde's Electrical Machines and Drives. It's an 800-page college level textbook for electrical machines, and it is the gold standard for the PE exam for rotating machines and transformers. It's one of the number one reference books that we recommend. And if you look in the reference book, you'll notice that they even use all of the notation from Wilde, and they use a couple of his diagrams. So you can tell they're getting most of the stuff straight from this book. Here's the thing, that's an 800-page book. Now, not all of it is dedicated to rotating machines and transformers, but a good chunk, anywhere from 25 to 50% of it is. So on the handbook, you only have 15 pages for these two subjects. You've got 8 pages for rotating machines. You've got 7 pages for transformers, right, out of the total 75 pages of the reference handbook. So if they're going to continue to ask these really qualitative, difficult theory questions on rotating machines, what are the torque relationships like with speed, compare breakdown torque values, compare how they are made, and maybe what are the different insulation types or characteristics of different NEMA designs of different motors. If they're going to continue to ask that level of difficult qualitative theory questions, we're going to be in trouble, because historically we've relied on using reference book like Wilde's Electrical Machines and Drives to answer these questions. Typically we save these questions for the end of each session, and then when we're down to the last 5, 10, 15 questions in each session, where it's like, man, this is really difficult. I don't know this off the top of my head. I know I've read something like this. Let me just dig through all these reference books to find it. We can't do that anymore. We've effectively been hamstrung in terms of the amount of reference material we can bring. So it's going to be really difficult if the qualitative questions continue to be this difficult for transformers and rotating machines. Now, on the quantitative side, right? When we're talking about solving math problems, right? On the math problem side of rotating machines and transformers, they're usually not too bad. The calculations are pretty quick. But, electrical engineering in general, you need to know the right formula, the right equivalent circuit model. It's not as, sometimes you hear plug and chug. It's not as plug and chug friendly. It's not as friendly to just find the formula and apply it. If you do that, chances are you're going to get it wrong. So luckily, the reference handbook was generous to include some of the equivalent circuits. And in my opinion, that's where the quantitative math questions are most difficult for these two subjects, are the equivalent circuits. So let's see, they included the equivalent circuits for transformers, synchronous motors and generators, and induction motors and generators in general, right? These are the equivalent circuits you're most used to seeing. And they also included the equivalent circuits for the open circuit and short circuit tests for transformers. Now, equivalent circuit questions, again, they tend to be difficult. The open circuit and short circuit tests tend to be even more difficult because, again, you have to know how to interpret what the question is telling you to set up the circuit correctly. Luckily, again, they gave it for transformers, but unfortunately, they did not include the equivalent circuits for induction motor and induction generator, no load and locked rotor tests, and they didn't include the equivalent circuits for the open circuit or the short circuit tests for synchronous motors and synchronous generators. So again, I expect this to continue to be two of the tougher topics in terms of both qualitative and quantitative. Maybe it's not as complicated as symmetrical components, but these two subjects definitely appear a lot more often. So with just about zero information included on theory in the reference books, either they're going to have to change the level of difficulty or the test is just going to get harder. It's really that simple, especially with the introduction of the new AIT alternative type questions where you kind of have to fill in the blank or match questions. These subjects I think are going to continue to be some of the more challenging subjects on the PE exam. Last, make sure you're familiar with the equivalent circuits that are not included in the handbook for induction motors and generators, no load and locked rotor tests, and the open circuit and the short circuit tests for synchronous motors and synchronous generators. All right, we're almost to the end. Final thoughts on the new CBT reference handbook for the electrical power PE exam. Like we discussed earlier, the power exam, it's one of the hardest, and we already looked at the pass rates. It's 50% for first timers, 26% for repeat takers. This is the lowest out there, period. It's one of the hardest PE exams. And when you really stop and think about why is this so much harder than civil and mechanical, which tend to be some of the bigger exams in terms of how many engineers are taking them, right? Why is the power exam more difficult? So in my opinion, some people might fight me on this. Of course, I'm an electrical engineer, so I'm biased. I think electrical engineering is one of the most difficult disciplines of engineering. I would probably say, I wouldn't argue that chemical engineering is probably a little bit harder, but they pass. They pass more often than electrical engineers on the PE exam. It's also interesting, less chemical engineers take the PE exam, right? Less chemical engineers need the PE exam for their career. But electrical engineering, it's one of the toughest, I might upset a lot of people, but I'm sorry, it's more technical than mechanical engineering. It's more technical than civil engineering. I'm sorry, I don't mean to hurt anyone's feelings. And again, I'm biased. But why is the power exam so much more difficult? Why are the pass rates so much slower? It's a mix of qualitative and quantitative, right? It's a mix of breadth and depth. The math, again, tends to be simple, but it's so easy to make a mistake. If you're not really familiar with the nuanced differences of each of the different subjects, you're going to make a mistake with the square root of 3. You're going to make a mistake with phase versus line values, right? The question is going to give you a value and you're going to think it's a phase value and plug it in. It was really a line value, or vice versa, right? Same for phase and line current. Electrical engineering is saturated with complex math, right? Multiplying, dividing, adding, subtracting, polar numbers, rectangular format numbers, applying the conjugate for complex power calculations. Complex math is saturated in electrical engineering. So it makes it even more difficult on top of that. Next, after complex math, once we get comfortable with this, we got to learn the per unit system, right? Again, kind of like symmetrical components, no one likes the per unit system at first. Very rarely do we use this stuff in the industry anymore outside of maybe transmission planning. So the per unit system, converting between actual values, using your base values to get into the per unit system, and then all of a sudden all the square root of threes disappear once you're working within the per unit system when you're on the per unit value level, even for three-phase systems, right? If you don't believe me, I'd be happy to show you, but it's complicated, right? It's nuanced. Using the correct voltage in a specific voltage zone, the voltage bases are going to change depending on the transformer, but the power base is going to stay the same. After that, delta and Y relationships. Phase versus line for voltage and current. Your formulas change, right? The I squared Z and V squared over Z formulas change at the three-phase level. Sometimes there's a three multiplier, sometimes there's not. And you got to be familiar with why it's there sometimes and why it's not. You got to be able to derive this stuff and intuitively understand it in order to do that quick, simple calculation correctly. Otherwise, you're going to find a formula that looks right. You're going to plug in your numbers, hit enter, and then you're going to select an answer on the PE exam that is a trap answer, right? NCEES, they're notorious for doing this. They will solve a question using one of the more commonly ways to solve it incorrectly, and they include that as an answer choice. So they're going to bait you with answer choices using the opposite relationships, and if you accidentally use the wrong relationship when you apply the math, you're going to get it wrong. You're going to select the answer, the number's going to match your calculator, you're going to smile, you're going to feel good, you're going to think you got it right, you're going to select it, and you're going to unknowingly get it wrong. Right after that, the list goes on. Single phase versus three-phase relationships. Once we get comfortable with all of this stuff, now, you got to learn how do unbalanced relationships affect all this. Something that's not even here is negative sequence. As soon as you get comfortable with all this stuff, especially the phasor relationships and phasor diagrams, and what is leading and lagging on the phasor line value for voltage or current, what happens when it's a negative sequence system, right? It's all backwards now, right? After that, you've got Kirchhoff's voltage and current laws. You've got complex equivalent circuits for transformers, rotating machines, symmetrical component faults. The list goes on and on and on. I really believe that electrical engineering, when it comes to when they test you on it, it's just one of the most technical subjects you can ever learn. So it makes it very difficult to pass the PE exam, right? Passing the PE exam in electrical power is very exclusive. It's one of the lowest passing rates. So to sum all that, up, final thoughts on the reference handbook. It's important to note that we have to have faith. NCEES, they have a lot of experience transitioning exams from paper and pencil format to CBT. They've already successfully transitioned all of the FE exams, right? For a couple of years now, every single FE exam, Fundamentals of Engineering, has already been transitioned to CBT. After that, I looked at the list and it even surprised me. There's been more PE exams than I thought. I think it's like 5 PE exams they've already transitioned. They just did the mechanical one before the power one. Now they're doing the power one. So they've transitioned a lot of paper and pencil exams to computer-based testing format. However, unfortunately, the concepts that are tested on the electrical power PE exam, I think it's going to pose a much greater challenge to NCEES compared to any other PE exam or even FE exam that they've already transitioned. So after reading every single page of the reference handbook and talking about the above, I'm left with these final questions, and I'm sure you're kind of left with these same questions, so we'll adjust them. The first question is NCEES going to change the level of difficulty of the questions to make passing the exam more realistic with only the reference handbook as the sole supplemental reference material? Of course, we don't know, right? It's too soon to tell. If they do not change the level of difficulty that they've historically tested on, it's safe to assume the exam is going to be a lot harder, just due to the simple fact of lack of references that are no longer permitted in the exam. And instead, all we got is the extremely simple reference handbook that's provided, right? Good luck with the transformer and rotating machine qualitative questions. Good luck with, magnetic saturation questions, volts per hertz, XR ratio. You can really get into some really technical theoretical questions that without a reference book, it's going to be tough. The electrical exam tests on every discipline or every lane of electrical engineering. Your industry might only be one subset, right? Maybe you're a MEP engineer working in the construction building industry, right? And you're stamping documents, and that's why you want to get the PE exam so you can sign off. Most of what you're faced with day in and day out is the code book. Very rarely would you, have a really in-depth theory on rotating machines. Now, an electrical engineer may be in a research position designing electrical machines, then sure, they're going to know that stuff, but they're not going to know maybe the protection side of engineering. So it's really difficult to answer these questions without having a small library with you. All right, next, question number 2. Suppose they don't change the question difficulty. Are they going to change their scoring methods? In other words, if they don't change the question difficulty, it's pretty safe to assume that the exam scores are going to go down. It's just going to be harder to answer the same number of questions. So to compensate for that, are they going to maybe change their scoring methods so that the same approximate number of engineers pass on average? Are they going to do some kind of bell curve? Are they going to keep the pass rate around 50% and artificially, curve scores to make up for it? And again, we don't know. Unfortunately, it's too early to tell. So if the questions don't change, expect the scores, unfortunately, to go down. And that's going to mean that the PE exam with the lowest first-time pass rate of 50%, it's only going to become even more exclusive. All right, last question. In the end, will the transition to the CBT format make passing it easier or harder? With all of this we've talked about, I think the first year of the CBT format is going to be much more difficult. I think NCEES is going to probably have to respond to feedback and pass rates, and I think the CBT power exam, it might be a work in progress for the first year or two. So really curious to see how it pans out. If you can at all take the October exam that's coming up, the last paper and pencil, knock it out. Try to get it done before you're part of the new group taking the new CBT exam. All right, I'm sure you're all very interested in how can you print and look at the reference handbook for yourself. It's really simple. You just go to nces.org, or if you use this link to go straight to the login, you're going to click on My NCEES. Careful, right? You got it on the top right and the bottom left. But down here, log in and create your account. Click on this My NCEES button to get to the login window. After that, type in your username or your email address and your password. Hit login. Next, that's going to take you inside your NCEES dashboard. On the right-hand side, you're going to see something that says Useful Documents, and it's going to say View Reference Handbooks. Click on that. Click on View Reference Handbooks. Then it's going to take you to a list of all reference handbooks. And now you're going to click on I know it's kind of hard to see, but click on the PE Electrical and Computer Power Reference Handbook. You can even use Control F in your browser, type in power. It'll highlight it for you to make it easy to see. Click on it. After that, depending on your browser, you'll either download the PDF, or the PDF will open up in a new tab, and you can right-click Save As, or maybe File, click Save As, and then you'll have the copy of the Power New Reference Handbook to look at for yourself and to make your own opinion. Now, a couple of useful links. Here are just some interesting things NCEES has put out. First, the exam specifications. You need to be familiar with this if you aren't already. Regardless of what shows up in the reference handbook, this is the exact outline of what you're being tested on. So this is just as important as the reference handbook, if not more important. Next, just in their general article on transitioning to the computer-based testing, here's the electrical and computer PE exam page. And here's where they're talking about how they were moving forward. So traditionally, or prior to this, it was going to be available starting April 2021, but due to all the concern with COVID-19 and the coronavirus pandemic, they moved it up to testing in January 2021. So after this October 2020, it will be the very last electrical power PE exam offered in paper and pencil. After this October, your only option is to take the new CBT PE exam. All right, that's it. Questions, thoughts, or comments? You got any questions? You want to join the discussion? Have you read through the handbook? What do you think? Do you think they're going to have to include more information? Do you think, what do you think about protection? Why do you think protection's missing? Do you think they're going to give us access to code books somehow or another? Let me know. Drop a comment down below, join the discussion, and let's get a healthy dialogue going. All right, good luck to everyone taking the computer-based testing exam. Like I said, really only time will tell, unfortunately, to have all of these questions answered. It's a really new and interesting time for the electrical power